You can change the RAID level. There are some rules. Generally speaking, a RAID 10 can be changed into a RAID 0. Well, when I attempted that, it crashed. And today we're going to be looking at RAID, and I'm going to be talking about some of the different kinds of RAIDs that are available for Linux. This is part of the Linux internals class, and I wanted to make sure that we added RAID. There are basically three general types of RAID. There is a firmware RAID, and we'll talk about what that is. You're probably familiar with the other two, though. There is hardware RAIDs and software RAIDs that are around, and that's what I'm going to be talking about today in this video. To set the stage for those of you who don't know what RAIDs are, they're a redundant array of independent disks, or as it was originally called, redundant array of inexpensive disks. They were invented by David Patterson and Garth Gibson, also Randy Katz, in 1987. Those three gentlemen were doing a study to show how adding smaller drives, about that time the small form factor 5¼ inch hard drives were around. They were looking at combining those in a way that would allow them to outperform the mainframe disk drives that were available at the time for a fraction of the cost, which they were successful in showing. And hence today, that's why you don't see mainframes with large disk drives anymore. And what do I mean by mainframe disk drives? Well, these would have been platters in the size of 10-inch to 14-inch platters. And it showed how they could also implement these RAIDs as either using a software solution or using hardware devices to do it. But RAIDs come at a downside. It shortens the mean time to failure. So let's say you have a hard drive that has a mean time to failure of 5 years, and in 5 years you can expect a certain percentage of those drives to have failed. When you add in more drives and form a single system out of that, you have to sum that mean time to failure together to get a more accurate picture, because you are, by increasing the number of hard drives, you are also increasing your chances for a failure. So the big idea about RAIDs is they allow you to combine multiple devices, such as hard disk drives or solid-state devices or NVMe, into an array. And that array is then presented to the system as a block storage device. That can also increase the performance by adding drives adds bandwidth to the storage array, so it means it can process additional data faster. So it also provides a layer of redundancy in some cases. It depends on the type of RAID that you configure. But the RAID appears to the system as a single logical storage unit or a drive, so that's the way it looks. And it doesn't matter if it's implemented in hardware or software. So what is this firmware RAID? So it's also known as an ATA RAID. Those are configured basically in firmware-based menus. Those firmware hooks into the BIOS or the UEFI console that's part of your motherboard. And particularly on system motherboards, it's more prevalent than it would be on a home one. But there are some in workstations where you can configure RAIDs. By doing so, that allows you to boot directly from the RAID, so your operating system drive can also be installed on a RAID. Vendors, however, use different metadata formats, and that creates a problem if you're trying to move a RAID developed on, let's say one particular vendor platform to another vendor's platform. It would probably not be able to get there. You would have to reconstruct the array and reload it from backup because of that metadata incompatibility. That's one of its problems. So it's not easily moved from one vendor's computer system to another. Now, if the computers are the same vendor and the same model, yeah, you might be able to do that. However, even the same vendor's computers could differ in the metadata from one model to the next because of improvements that they make to it. So Intel's Matrix RAID is an example of one of these firmware RAIDs that have been around for quite a while. The other one is hardware RAIDs, which you probably have seen or more familiar with. Those are hardware RAID cards which manage the RAIDs independently from the host machine. So they're an add-on board that has some intelligence in managing the devices that make up their RAID, and they do not show up in any shape or form. The individual devices do not show up on the host hardware at all. So unless it's a host base, unless it's a host, an HBA card. So the RAID device presents the RAID array to the host, not the individual drives. So you do all your configuration, you do all your recovery, you do your reconstruction, you do your scanning on those drives from the utility that runs on the card. So hardware RAID devices can be internal or external to the system. So there's a number of external connections that are supported: iSCSI, Fiber Channel, InfiniBand. There's other high-speed connections. RAID cards handle all of the actual disk communications. So software RAIDs implement various RAID levels just like the other two do. However, the code for that is usually kept inside the kernel. It is the cheapest solution, and it works with any block-level device, whether it be SATA or SAS or NVMe. There are even Thunderbolt carriers which work as well. Software RAID usually outperforms hardware RAIDs today, and that's mainly because of the performance increases in the CPU over time. Software RAIDs are able to take advantage of that. Linux uses a multiple device driver called the MD driver, and we'll talk about that. Some of the key features of a software RAID over any of the other two is that it does support a multi-threaded design. Now, there are hardware RAIDs that do that, but you do have a single point of failure, and that's the host controller itself. And you usually have to put in multiples of those and do all kinds of gymnastics in order to have redundancy on the data path. So there's portability of the RAID between Linux machines without reconstruction. So as long as I'm using the MD driver, I can move this possibly even from one vendor, one distro to another distro, not just from one machine to the next. So as long as they're on a compatible version, there should be no issue in doing that. If you do require reconstruction, that will background, and the array will use idle system resources to do the reconstruction. So it will not hammer the server any harder than it has to in order to provide that reconstruction of that array. So there's also hot swappable device support. It also does automatic correction of bad sectors. There are regular consistency checks of RAID data, and you can create proactive monitoring of the RAID array, and there's a lot of other features there as well. And we'll be looking at some of those today. So the types of RAIDs that you can create are basically four. There's actually three additional ones, and I'll talk about those in passing. But RAID 0 is a striped array, and there's no redundancy. So if you lose a drive, you lose the array and you lose your data. A mirror allows you to have at least two drives, and that will then copy the file into both places. There was RAID 2, 3, and 4. 4 is still in operation, believe it or not, but 2 and 3 were experiments. They did not pass muster, so they didn't go any further. 4 is still around, but 4 has some issues. RAID 5 uses striping across at least 3 drives, and it does single parity, which means that there is one copy of the metadata on each drive. So if you lose one drive, you are able to recover. RAID 6 came about because it was discovered that a lot of these drives are the same age, and when you have a failure, the reconstruction process can be fairly heavyweight. A lot of activity, a lot of disk motions going on for hours and days, sometimes maybe even weeks, depending on how large the array is. And that could induce another drive failure. And in a RAID 5, additional drive failure would be a catastrophic loss of the array. RAID 6 was developed in order to give you a second chance. So it is also striping, and it uses dual parity, which means that each drive has at least 2 copies of the parities to reconstruct itself with. So you can lose 2 drives. There are also a number of hybrid RAIDs, which aren't really RAIDs at all. They're just combining more than one in order to be able to address some of the issues with like RAID 0. So there's RAID 10, which allows you to create a pair of RAID 0 drives and a pair of RAID 1, which give you the speed of the striping and the redundancy of RAID 1. There's also things like linear RAID, which is basically just a bunch of disks. Again, that's just concatenating disk space together. It's not really a RAID, but it allows you to do that. MD RAID is a subsystem that was designed as a software RAID solution for Linux. It is the preferred solution for Linux software RAIDs, and it uses its own metadata format called native MD metadata, and it's controlled by the MD-ADM utility. There's also an MD monitor utility that allows you to monitor the health of the RAID array and then send alerts in the event that it needs to. I'm not going to do a demo of this, and I'll talk about that, why I'm not going to do that in the conclusions to this video today. But what did we talk about? So we learned that there are basically 3 major types of RAIDs: the firmware, hardware, and software. We learned a little bit about where it came from and why. RAID's been around a long time. Personally, I feel its time has passed, and it's time to move on. RAID takes a long time to do reconstruction. Scaling into the petabytes of storage that we have today requires reconstruction times which can last for several months. So yeah, that's unrealistic. That's really unrealistic. Plus, based on the size of that data pool, where do you back it up? How do you back it up? They always used to say never back up a RAID to another RAID. But really, that's about the only way you can do it. So yeah, not good, not good. But we also talked a little bit about the differences that software RAIDs provide, and that they are generally faster today than hardware RAIDs. Now, there are some exceptions. There are some new hardware RAID cards that are coming out that allow for very high-speed data access and data transfers. Okay, so today I'm going to be on Red Hat 9. This is Red Hat Enterprise Linux version 9. And I'm going to be using the MD RAID and the MD driver in order to set up an experiment with a software RAID under Linux. And so the command that I'm going to run is MD-ADM, and we're going to give it a command type create, which tells it the action to perform, of course. We're going to give it a device name, MD0. I'm going to set the level equal to 10, which is a RAID 10. And then I'm going to say, okay, so look for 4 devices, because in a RAID 10 you have 2 RAID 0s and 2 RAID 1s. Now we'll just assign the devices that we want it to use. SDC, SDD, and SDE. Okay, it has created the array, and we can validate the block device is there. You can see that it has today's date and time just a few minutes ago, well, a few seconds ago. Let's move on. And so the next step I want to do is I want to create, let's take a look at it and make sure that this is what we wanted. And you can do that with a detail command to look at what's actually in here. And you can see that, okay, so it did create a RAID 10. The size of the RAID is about 68 gig, and then each device is contributing about 32. So that's right, because that's the size of the virtual drives that I assigned to this virtual machine. There are 4 devices. Superblock is persistent. It is resyncing because it is initially laying out the structure on that, and so we should wait for that to complete before we go any further. Okay, it's done. It's clean. So we're gonna lay out a file system, and you do that just the same way you do with any file system, except I'm gonna give it the block device that I just created. So okay, it has created the file system, and now we should be able to mount it. Let's put it on SRV. Right, 64 gig. Shouldn't be anything on it. Let me purge that out of here, and then we'll go ahead and get started. I'm going to go ahead and benchmark this, so I'll be back when this is done too. Okay, so our benchmark is completed. So the next thing I want to attempt to do is there is a mechanism by which you can change one RAID level to another. But there are some rules. For example, this is a RAID 10, and according to the manual at Red Hat, it has a manual called Managing Storage. And in there it says that if you have a RAID 10, the only thing that you can change it to is a RAID 0. So, all right, so the command to do that looks like this. It's grow. And you give it a level. This time we're going to give it 0. The number of devices is 2. And let's see what it does. Okay, it changed it. So let's see. Oh. Uh-oh. It froze up. It froze up. Okay, let's okay, now that kicked me out. It kicked me out. Okay, I have a device, but it says it's inactive. Did it unmount it? It unmounted it. Okay. And device SDC. Let's see what we got here. We have it's active. Okay. Says it's clean. Can't read the super block. So it's supposed to, what it's supposed to do is it's supposed to preserve the RAID. And it doesn't look like it completed the migration because it crashed. It crashed. And this is not right. This is not right. Shouldn't do this. So it looks like we have a corrupted RAID here. Let's see if I can make a file system on it. I'm going to force it. No, it's not happy about something, is it? Yeah, it's corrupted it. It's completely corrupted it. Oh, great. Great. So I can't go any further with this. So we've got a bug on Red Hat 9. Let me go set up, and I'll try all this again on Debian, and I'll be right back. Okay, I'm back here on Debian. So I have a This is a RAID 10 that's already built. It's not mounted though. Oh yes it is. Okay. It's mounted. So let's just see if it's working. Let's see if we're at the same place where we just left off. So I mean I did the same commands over here to get this far to create. So the only difference is this is Debian instead of, yeah. All right. So let's, otherwise we won't be able to create any test files on the RAID. So all right, I'll be back when this is done. Let me just leave that exactly the way it is. So I'm going to leave it mounted just the way I did that on Red Hat. So mda/adm grow level equal to, 0. Number of devices 2. MD0. Okay. I'm still alive. So, all right. Oh, yeah, it might help to give it 2 text. All right. So this should be rebuilding, but it's clean. Okay. So we're good here. And our mount is still there. We haven't lost any data. Let's see what happens if we run the benchmark again on it. And now this shouldn't be as performant as the last one. But I'm not benchmarking these. I'm just trying to put some load on it to see if I can get it to crash. The way I understand this, now let's make sure that we have looked at this in detail, because what should have happened, and yes, it did. So this was the I think this was the B. This was the set B. So yeah, it's removed set A and the 2 drives for that, which were SDB and SDD. So they're gone. So we know that we need to add those back. So all right, so let's see if we can reverse this. All right, we'll put in the grow command. And we want level equal 10. And 4 is the number of devices we want. And the device is MD0. And we want to add, now this is not covered in the manual, SDB and device SDD. All right, so it added it. Let's see what, now it should be reconstructing. And yes, it is. It's marked it as degraded and it's recovering. So we don't want to touch this until this is done. It's clean. It's done. So now we've got an active set A and B. So let's put it to the test. Okay. Well, it was, as far as the move is concerned, everything is successful. So what do I want to do next? So I think what I want to do is show you what happens on a failed RAID. So, you know, the thing that you want to watch for is start looking for this. So you can see that yeah, this was the after the mount. So this was when we were converting this from a RAID 10 to a RAID 0. It marks it as a failure on those drives and it disables the device. That's normal. That's normal. But if you were running along in real time and you start seeing that you've got disk failures, then you've got a problem. You've got a problem with your array. So the way you do this is, let's do this first. To make sure that I'm going to grab set, I'm going to disable. Well, see, I don't have. All right, let me go add a device. So I've got, let's see, 1, 2, 3, 1, 2, 3, 4. All right, so I need to add another one. Put it on the ZFS pool. All right. So now it should have F, and it does. There's F. Okay, so what I'm going to do is I'm going to mark STD down. And you do that by saying fail STD. Boom. So now if I do a details on this, you'll notice that this device has been removed and we're in a degraded mode. That device is dead and it's marked down here as faulty. So it kicked it out of set B and it marked it as faulty. So the next thing I want to do is guess. I want to remove it, right? I want to get rid of that device altogether. So let's do that. I don't even want it part of the array. Just get out. Okay, it's gone. And now I need to add back the new drive. And so that one is done this way. We'll add that there, and we'll change this to an add. Boom. And now you see it staying. See how it marked it? It added it as a spare. It's now placed the array into recover. So we're going back through the RAID recovery again, and this time we're working up on a new drive. So, and then you wait until this rebuild thing is done. Okay, we're now clean. Everything is set and it's running okay. So let's see. Let me just shorten this up. I just want this right here. So I think as far as wrapping up the demo part of it here, anytime this is personal experience. So anytime you're moving RHEL from one major version to the next, like going from 8 to 9, for example, it seems like today there's always major bugs that happen with the system. So, and that clearly is what's happened here. So I think that is a bug that, obviously if you're trying to grow the array and it's supposed to be able to do that, it shouldn't blow up, destroy your RAID, and then throw you out of the system. That's one of the things I like about, people give Debian a lot of static about it being old and out of date. But, if you're conservative and you're trying to make sure that whatever you're doing works, I would be more inclined to be on something that's old and out of date and stable than something that is brand new and it blows up all your data and throws you out of the system. So, yeah, I don't. Yeah. Anyway, that's all I had.